Young people, welcome back. B&B in the house, y'all. Ready to take care of some functions. That's right. So let's read up on it. Let's see what they got, guys. Chapter 1, Lesson 7, Functions. Objective 1, determine whether a relation is a function. Objective 2, find function values. All right. So before we get started, guys, of course, students will be able to, just like they said, determine if a relation is a function, and of course find or evaluate functions. So the concept is functions. The skill is evaluating them and determining, identifying, because it can be a function or it cannot be a function. So just taking a second right now to make sure you're clear on the relation and whether or not a relation is a function. So think about it like a vending machine. Stole this one from AP. Don't even worry about it. It's a good example though. So you go to a vending machine, right? Soda machine, and you see all the buttons. Coke, Pepsi, Sprite. And you press Coke, and then a ginger ale comes out. This doesn't make sense, right? Yeah. Should get a Coke, because the relationship between that button and the soda should make it work. So what if you hit the Pepsi button and another ginger ale comes out? You know that's a broken function. It's a broken system, right? So here's the statement that I'm going to use, and you're going to hear going over and over, that for every input, there's exactly one and only one output. For every range, you can only have one domain. So think about it. In your function box, something goes in, something comes out. Think about the relationship between height and age. 10-year-old, 4 feet tall. 12-year-old, 4.5 feet tall. So for every input and age, an output comes out, their height. So that's a function, the relationship between two values. And of course, whether it's a function or not, determines if that domain, the x value, what's going in, when it comes out, should only have one and only one value. So one more example of that would be, again, the soda machine. It's a perfectly working soda machine. You used it every day. Come up, you press Coke, the Coke comes out. Come up, you press root beer comes out. You come up, press Sprite, Sprite comes out. But one day you come to the machine and you press Coke, Coke comes out. Good. Then your homeboy wants a Sprite, so you press Sprite and Coke comes out. Well, then that's not a function, because for every input, there's only one output. There can only be one Coke coming out of there. All right. So I know that might be a little shaky, but that's what I'm giving you, and we're gonna get started. So I'm gonna keep talking about it, and there's other handouts too where we talk about mapping and relationships, and we're gonna do it right now. Get her started. So determine whether each relation is a function. Guys, we've got a lot going on over here. And honestly, it's gonna go fast, but again, I can pause and slow down. So number 1 is yes, number 2 is yes, and number 3 is no. And already, guys, I'm going to tell you why. For number 3, the input of 4 has 2 outputs. The domain 4 has 2 ranges, 2 and 5. So for all the others, you'll recognize that for every input, for every x, there's only one y. But for number 3, for that 4, there's 2 arrows coming out. So it fails the arrow test. Only one arrow for every input. And then the next is a table. So 1, 2, and 3 were mappings. 4, 5, and 6 are tables. So in the table, my x values, y values. So yes, there are no repeats in the x values. But for 5, I see a repeat, meaning it's not a function. And again, the reason it's not a function is because the domain 5 is in that table twice, meaning 5 gives me -3 and 5 gives me 2. Can't have that. 5 can only give me one range. Remember, if I hit 5, 5 better come out. I can't hit 5 and the 5 come out and then the 2 come out. All right? So same thing for 6. It's a no, and it's because of the doubles again. With the domain 3, I have 2 ranges, 7 and 5. So when I'm seeing them listed as such, I kind of understand. Whether they're listing it in a mapping in 1, 2, or 3, or they're listing it in a table. So 7 and 8, the same thing, they're just not in a table. So I'm looking for doubles. There are no doubles in 7. But in 8, wow, right there. I got a 6 and -1. And I got a 6 and 5. You can't have doubles. So therefore, no, it is not a function. Because again, for each domain, you can only have one range. So 6 is a domain, it can't have 2 different ranges. Now for 11, 12, and 13, I really do hope your teacher showed you the vertical line testing class. If not, there's plenty of places to go get it. But wait, I skipped 9 and 10, huh? I think we need some room, y'all. Let's make some room. There we go. So, gonna get a little bigger for you, but not today. We're working on it. However, for number 9, it says y is equal to 2x minus 5. Yes, because no matter what x is, you're gonna get a value for y that's different every time. And for 10, same thing, 11, 12, and 13 though. 11 is a yes, 12 is a no, and 13 is a no. But y is 11, 12, and 13 what they are. Let's talk about it. So as I mentioned before, the vertical line test, what happens is you take a vertical line and you go across your graph and you're looking for doubles. And right there in 12, you see doubles. There's 2 on that vertical line. There can only be 1. Because again, for every domain, for every x value, you can only have 1 y value, 1 range. And right there, it fails because at 2, the y is 2 and -1. Can't have that. And same thing over here as well. It fails the vertical line test because it crossed the line twice. The other one had 2 points on the line. The other one literally crossed my vertical line twice. So vertical line test, mapping, and of course the table, determining if it is a function or not. Honestly, looking for any domain that has more than 1 range. Now here's what's really going on. We're going to plug into the function. So if f of x is equal to 3x plus 2, okay, we're going to find f of 4. But where I see x inside of that function, I'm going to plug in 4. So 3x becomes 3 times 4. And of course, 3 times 4 is 12. 12 plus 2 is 14. So for 16, f of -2. So again, f of x is 3x plus 2. So I'm going to say f of -2 will be 3 times -2 plus 2, which will give me -6 plus 2, which is -4. So the same process, but now with g, I've got a different expression inside of that function. G of -3 is equal to x squared minus x. So parentheses, -3 squared minus parentheses, -3. So in this case, guys, nothing different, just a different plug-in to take care of. -3 times -3 gives me positive 9. And of course, a negative of -3 is positive 3. So 9 plus 3 gives me that 12. Got it. And moving on to f of 2, and now they're adding to the function. Literally, they're adding 1 to the function, f of x. But we know what they want us to evaluate, f of 2. So f of 2, go ahead and do the function component first. 3x plus 2, plugging in 2 for x. So 3 times 2 plus 2, and then of course adding the 1 to the entire function. So end up getting 6 plus 2, that quantity plus 1. So 8 plus 1 gives me 9. And for 22, same thing, they're adding, or actually I take that away. They're subtracting from the function. G of x, in this case, g of 2 minus 2. So for the x squared minus x becomes 2 squared minus 2, but I have to recall and remember that they're subtracting 2 from the entire function. So therefore, go ahead and do your 2 squared, gives you 4, minus 2, then another minus 2, so 4 minus 2 minus 2 gives you 4 minus 4, which is 0. And for 24, 23, thank you very much, 24, f of x plus 1. So we've been in the habit of plugging in a single value, like 2 or 5 or -3 or 4. Or now where I see x, I'm plugging in the binomial that I see inside of that function. So f of x plus 1 is equal to Woo! 3 times the quantity of x plus 1, all plus 2. So there it is where it was 3x plus 2. Well, now it's 3 and replacing x with x plus 1. So 3 times x is 3x, 3 times 1 is 3. Bring down the plus 2, and I got my 3x plus 3 plus 2, 3x plus 5. I like it. I hope you do too. Of course, moving on, we're jumping back to 15 up there. And just 3 times x plus 2. This time, x will be replaced with 8. So 24 plus 2, which gives you 26. Next one, g of 2. And I've got the x squared minus x, so 2 squared minus 2. And again, 2 squared would be 4. 4 minus 2 would give me 2. And then, of course, moving on again to another g of x. In this case, g of negative 6. So negative 6 to the second power minus 6. And of course, a negative times a negative is going to give me a positive, so 36. And then a negative of a negative is positive, so 36 plus 6 gives me that 42. All right, guys, so let's get these last 3 in here too. We're going to get some room, though, for 21, 23, and what do we say, 25. Maybe, no, maybe very much. 21, f of 1 minus 1. So we're doing the f of x function, the function of x, and that function is 3x plus 2. That's like the function box, that's what's going on with it, that's what goes inside, and then what comes outside. So when I put a 1 inside of that function, and then I subtract 1 from that whole entire function, what will we get? We're going to get 3 times the quantity of 1 plus 2 minus 1. 3 times 1 is 1, plus 2 minus 1. So 3 plus 2 is 5, 5 minus 1 is 4, and you can say that f of 1 minus 1 is equal to 4. Real important that you remember that minus 1 is part of it, right? For 23, it's the same thing, it's just the second function, the g of x. And this one has a little bit more going on because g of x is equal to x squared minus x. I gave him some color love there. So again, recognizing f of x is just that first component of the expression that we're simplifying. And when we plugged in 1 for x, we had 3 times 1 plus 2, but bringing down that minus 1, correct? So for 23, again, g of negative 1, and then add 4 to that function. G of x was x squared minus 1. So we're going to get parentheses squared minus parentheses. Did I say minus 1? I'm going to say minus x. I'm sorry, guys. So negative 1, probably why I said it, goes inside the parentheses, the first one and the second one. And again, a negative times a negative gives me positive. A negative of a negative gives me another positive. So 1 plus 1 plus 4 gives me 6. And now I'm feeling good. Because 25 is a little different. It has a term inside for your evaluating. So when they say evaluate the function, okay, what do you want me to evaluate? 2, what was it, x plus 1, negative 1. Well, this time we're evaluating 3b. So g of x was x squared minus x. So now g of 3b is going to be 3b squared minus 3b. And of course, 3b squared is just 9b squared, and nothing happens with that second 3b because they're not like terms. And guys, great job. Again, I want to say that functions can be a little confusing, but kind of when you get it, right? Again, the definition of what you should walk away with this is you can identify a function by knowing that for each domain, there can only be 1 and 1 range. So as I plug in a value for x, and I get a value out for y, that x better have the same value, cannot be repeated. All right, guys, once again, thank you for coming in. Can't wait to see you in the next video. B&B out.